And here we go with example 3 of integration by parts. This time we have a definite integral, so we have to be a little bit more careful, but it's exactly the same. We're just going to do an antiderivative, just like we did in the previous videos, and then at the end we're going to use the FTC2 and plug in the upper bound and subtract, plug in the lower bound. Should work exactly the same. So let's do it. Let's pick our u and our dv. What should we pick as which? We want to pick something that gets way easier when we differentiate it. So the derivative of ln x is 1 over x. The derivative, that's easier, I would say. The derivative of x to the fourth is 4x cubed. That's also easier. So it's a little trickier to pick which is your u and which is your dv. But if you think about it a little bit, here's my du and here's my v. If I pick it this way and I choose u as x to the fourth and dv as ln x, I would have to integrate ln x to get v. And the integral of ln x is not 1 over x. That's the derivative. We don't actually know the integral of ln x. That would require integration by parts, though I haven't done a video on it. So it's probably not a good choice. Furthermore, this is going to get worse when we... Actually, no, this is going to get... I was thinking we were integrating this for a second, but either way, it's not a good choice. Let's pick ln x as our u, and our x to the fourth as our dv. What do we get? Derivative of ln x is 1 over x. Integral of x to the fourth, x5 over 5. Now let's just plug it in. This is x to the fourth times, uv. ln x times this, x to the fifth over 5 ln x minus integral v du, x5 over 5 times 1 over x dx. I don't do anything with my bounds right now. I'm going to do the entire original integral and then plug in my bounds. So I have no bounds here. I'm not plugging in bounds here. We're just doing the integral still, the original one. So we got to find an antiderivative. So this is x to the fifth over 5 ln x. Here 1 over x cancels. I get x to the fourth. And what's the integral of x to the fourth over 5? Well, that 1/5 out front doesn't really do anything. It's just a constant, so I can just do it like normal. It's x to the fourth goes to x. Let me write it out, actually. The integral of x to the fourth over 5. I have 1/5. It's my constant. And then I still just do x to the fourth like normal. You see that? So I get x to the fifth over 25. X to the fifth over 25. And then here's where I plug in my bounds. So now, if you remember from Calc 1, FTC Part 2, I plug in 1 and I plug in e. Let's plug in e first. And I'm not going to simplify these logs just yet. I'm just going to write ln e. And then I subtract 1 to the fifth, ln 1, minus 1 over 25. Do you see that? I have to make sure, though, when I plug in the bottom bound, I put in brackets there. I'm subtracting a whole quantity. So, now let's do it. What's ln e? Well, think about it. ln e. What is ln? ln e as a question is e to what power gives me e? And the answer is 1. e5 over 5 minus e to the fifth over 25. Now what's ln 1? E to what power is 1? E to the 0 power is 1. So 1/5 times 0 goes away, and then I have to add on 1 over 25. And that's it. From here, I guess you could combine these two. They're like terms. Not super necessary. I would have to find a common denominator. 25. 5e to the fifth minus e to the fifth plus 1 over 25. And I could combine these and I would get 4 over 25 e to the fifth plus 1 over 25. But that's it. there's your answer.